Time series analysis can be applied to a variety of real-life problems, analyzing economic, social, and financial trends. But what about fashion trends? Can time series analysis be used to predict what goes in and out of fashion? In this project, I will be trying to answer this question by using around 10 years of data from the Google Search Index to predict interest in skinny jeans and determine whether they are coming back into fashion over the next 10 months. As we can see in the time series plot presented here, interest in skinny jeans was at its peak in 2015 and since then has been steadily declining, with seasonal patterns reflecting changing weather conditions. It also shows some signs of changing variance, particularly when comparing the earlier part of the series. The series also seems to be highly autoregressive, with each point following the momentum of those preceding. Comparing the first, 6th, and 12th lags, we see that the 12th lag is almost as strong as the first, further supporting the idea of seasonality. The Shapiro-Wilk p-value and the S-curve in the QQ plot shows the raw data are far from normal, with heavy tails and skew. The ACF decays slowly and remains high through lag 12, while the PACF has a sharp spike at lag 1 and another at lag 12 before dropping. Unfortunately, none of the transformations applied were able to achieve normality in the series, meaning we will not be able to use the ML method for parameter estimation, and AIC and BIC tables will not be included in the residual analysis as they rely on ML method to be generated. The first different series, however, was able to successfully remove the trend from the data with no additional improvements achieved through the Box-Cox transformation. The ACF plot of the first different series shows a cutoff after lag 2, while the PACF shows a trailing off pattern in exponential decay, indicating an ARIMA 012 model. The BIC table suggests a P of 1 and Q of either 1 and 4, leading to an ARIMA 111 and 114 candidate models. The EACF table, while less clear, suggests ARIMA 012, 014, 113, and 114 models. Using the classical approach for SARIMA order estimation, we see that the ACF of the original series displays clear seasonal patterns, which are not removed in the first differencing of the series. Applying first ordinary and seasonal differencing to the series results in a SARIMA 211, 111 model. Using the residuals approach, we see that the baseline model leaves a significant amount of structure left in the series, with one significant lag in both ACF and PACF, leading to a SARIMA 000111 model in the next candidate series. This series still contains leftover structure, so we apply the first ordinary difference for a 010111 model. From this, we observe two significant lags in both ACF and PACF with one season of the series, and fitting the 212111 model leaves basically no leftover data in the resulting time series. Keeping the seasonal orders fixed, we obtain a SARIMA 114, 111, 213, 111, and 214, 111 from the EACF table. From the BIC table, we obtain SARIMA 117, 111, and 217, 111. Upon analyzing the residual diagnostics, the SARIMA 213, 111 model was picked as it showed a strong balance of low RMSE, MAE, and MACE values, while also having 5 out of 6 significant terms. Following this, the Macleod-Lee test was conducted, showing significance at all lags and justifying the use of a SARIMA-GARCH model. ARMA was specified to be 3-3 in this model, as it captures the same structure as the SARIMA 213, 111 once the seasonal and non-seasonal differencing has been applied. A student's t-distribution was used instead of a normal distribution to better account for the extreme values seen at the tail ends of the series. The residual diagnostics show that while the model performs well overall, the residuals are clearly not normally distributed. Results from the forecast also suggest that skinny jeans will not be making a return, with decreasing interest over the next 10 months despite cold weather conditions. Given the non-normality of our residuals, however, this forecast should be taken with a grain of salt, as the model's prediction intervals and significance tests may be unreliable under violated distributional assumptions. Thank you for watching my presentation. I hope it's given you some insight into the unique applications of time series analysis and sparked some curiosity about how we can model real-world trends in creative ways.